Hello 515 students. Today we're talking about Introduction to Hypothesis Testing. This is a very important chapter for us because it's setting the basis for inferential statistics, meaning what we're going to do is try to collect a sample and infer something to a population. And specifically we're going to use a hypothesis test for that. And a hypothesis test is a statistical method that uses sample data to evaluate a hypothesis about a population. So we start out with a sample, as we see on page 235. Take a sample of that, and then infer back from the sample to the populations. We're introduced into the null hypothesis and the alternative hypothesis. The null is for example, no difference or some default condition, and the alternative is the alternative to that. And often we put the question in the alternative hypothesis. Those are discussed on page 236. We have the bell-shaped distribution or the normal distribution, and that's crucial to understanding what we're doing here. That nature, if you measure something in nature, it'll form a distribution of some sort, and a common one is the normal distribution or a bell-shaped distribution. And then we talk about the alpha level or the p-value, what we're going to see in our output called the significance level. The probability of value that is used to define the concept is very likely in a hypothesis test. And then we have the critical region where we reject the null, where when we observe something we think it's so extreme that we don't think it could just be by chance under the null, and hence we want to reject the null and make some conclusion about something. A key aspect, a critical aspect, is on page 244 that we talk about type 1 error. And then we can talk about type 1 error rate as well. So, and we often see that as the alpha level. So often it's proposed as when we have the alpha level, we can commit a type 1 error or a false negative, meaning we rejected the null when we shouldn't have. There's also the type 2 error as discussed on page 245, which is we failed to reject something that is different where we should reject it. And those are both very important concepts for us, and in the readings we should really try to understand what those concepts mean. And so what we're going to start out with is just to introduce ourselves to hypothesis testing, is we're going to do an independent samples t-test. And we're gonna use a type 1 error rate of 0.05, and we're going to compare these independent groups. So the null hypothesis, for example, might be that the mean of group 1 is the same as the mean of group 2 in the assignment. So here's our assignment, or example assignment, and it says enter the below data into SPSS, conduct a two-tailed t-test, and write up your results in APA format. Use type 1 error rate of 0.05 to evaluate your test. Now, because we have two independent sample groups, that means they're observations from different people. So in this case, if we had 6 people on this side, those are different people than on this side. So the concept of group is important in how we're going to enter the data here. So let's go ahead and enter the data. First, we want to designate what group we have, either group 1 or group 2. So as I come over to SPSS, I'm going to go into variable view, and the first variable I'm going to identify is group. The second variable I'm going to identify is observations. So then I'm going to go to data view, and then I'll go ahead and enter my data. The first group, so we have 6 observations in group 1. So I'm going to put 6 ones. 1, 1, 2, 3, 4, 5, 6. And we also have 6 observations in group 2. So I'm going to go ahead and enter 6 twos. Okay. So then I need to enter the observations. So group 1, the first observation was 2. So I'm going to go ahead and enter that. 2, 5, 4, 6, 8, and 2. Now I'm over at group 2 over here. And I'm going to enter that data for group 2. 9, 8, 7, 11, 13, 15. So then to evaluate if group 1 has a different mean than group 2, I'm going to go up to Analyze, Compare Means, Independent Samples t-test. First observation is test variables. That's our obs variable, so I'm going to go ahead and bump that over. And then the group, which is defining the group, so I'm going to click on that, and I'm going to bump it over into group variable. Now I need to define that. As you say groups, it gives me question mark, question mark. So I'm going to define groups, and my groups were 1 and 2. I could have put in 3 and 4 or 0 and 1. So my groups are 1 and 2. I go ahead and put those in. Say continue. At this point I can hit paste. And then I need to go to my syntax window. Okay, so t-test groups 1, 2. And then I'm going to go ahead and block that. So I'd go underneath the syntax. I hold my left mouse down and I'm going to drag it across. I can let go on the top, and then I'm going to go over to the green triangle, which is the run triangle. And I'm going to click on that. Okay, so we get some output here for this, and I had run it earlier, so I have two forms of output here. So I'm going to go ahead and just delete that initial output. Okay, so we get our syntax verification, we're getting our group statistics, and our independent samples test. So I'm going to go ahead and click on group statistics here, and I'm going to just copy that over to my assignment. Now, we note the table here isn't longer than the column. Sometimes it's difficult when we're copying information over from SPSS. And I want to copy this table, but I know it's going to be longer than the column width of my sheet of paper. So I'm going to go up to Edit, Copy Special. And I have some options of how to copy it here. And for example, one is an image or a meta file. Now, when I bring over an image or a meta file, it'll be scalable. I'm going to go ahead and just click Image, and I'm going to say OK. So that's copied it as an image file. And I can go over to my document, and now I can paste that in, and now it's sizable. Okay, I can increase it or decrease it, and that allows me to read it. Okay, so there's one other thing I'm going to bring in is my syntax. I'm asking you to bring in syntax that's used, so I'm going to go ahead and copy that over, and I'm going to bring that in right above my document. So at this point, we don't need SPSS anymore. We've done the calculations and put the output in our document. So at this point, then, I need to write up. I'm asking you to write up your results in APA style here in this. So this was an independent samples t-test. The mean of group 1 was 4.5. The mean of group 2 was 10.5. Here are their standard deviations and standard errors. As we know from last time, we could calculate our standard errors of these by taking the standard deviation divided by the square root of n in that case. So we know how to calculate everything in this top table here. We see that group 2 seems to be quite a bit larger, have a larger mean. It has 10.5 versus 4.5. The question then we have is, do we think this difference is due to chance alone? To do that, we're going to come down and read our independent samples t-test table down here. And as we see, the first thing is the Levene's test of equality of variance. One of the assumptions of the t-test is that the variances are equal. Let's skip that for now. We're not going to be concerned with that, but we are concerned with the t-value. Okay, that's our test statistic out here. That's like a z-value, but it's conforms to a t-distribution. A t-distribution is similar to a z, but it has wider tails. We see our degrees of freedom here. We had 12 observations. We calculated the mean of two groups, so we lost 2 degrees of freedom. We see our sig2 tail. This is our p-value in the test, or our significance level. And then we have the mean difference, the standard error, and the 95% confidence interval. In APA, in order to write up my APA value, I'm going to put what test it was. In this case, it was a t-test. Let me get a bigger font here. Okay, so it was a t-value, open parentheses, and what were the degrees of freedom? We see that right here in our value, degrees of freedom 10. Equals, what was the value of that t? We see it right up in our test here. So we're under equal variance assumed line. It was minus 3.795. comma, and then P. Now there's a couple different ways to do this. In our case, we're just after, was it greater than or less than our type 1 error rate? And then in the assignment, I asked to use a type 1 error rate of 0.05. So we're going to look at our sig value here, which is our p-value or level of significance, and we ask the question, is this value greater than or less than 0.05? And here we have a value of, our value was actually equal to 0.004. Okay, so let's just go ahead and say it was equal to 0.004. Okay, underneath that, I'm going to just repeat what I've just written. And so it was a t of 10 degrees of freedom equals minus 3.795 comma p, and because 0.004 is less than, so we end up with less than 0.05. So this is how we're going to write it up in APA format for us to view. And this is what I want you to do in the assignment, is go into your table and write up this value if it was greater than or less than 0.05. And if I was in a journal article, I might say the mean of group 1 was 4.5, the mean of group 2 was 10.54, its actual mean difference was 6, and it was statistically significant, comma, t, open paren, 10, close paren, equals minus 3.5795, comma, p less than 0.05. Okay, that's all I'm asking you to do for this assignment. You can go ahead and post it in like this, and I'll have an uploading slot for it. Thank you so much.